Early tests of the control system involved learning to fly it on a tethered test rig. Moore himself broke his leg when he fell on the concrete floor of the test site. A slight movement of the legs could set up a pendulum motion, which was not easy to control. By April 1961, Moore was ready to make the first free flight. The rocket engine used pure peroxide fuel, and the problem was that it could achieve only 21 seconds of burn. So the vision of continuous free flight presented in this sequence of a Bell Company film is a little fanciful. Early attempts to sell the idea to the Army were unsuccessful. The noise of the engine and the 21-second flight time were negative factors. But in spite of the apparent impracticality of the idea, Moore continued his experiments. He attempted to develop a jet version and succeeded in flying it, but there was still a noise problem and it was still heavy. Fully fueled, the whole rocket belt assembly weighed 120 pounds. It had a built-in stand that made it convenient for the pilot to strap in. The strapping in process was crucial. The straps were the pilot's only insurance policy. They were all that came between him and a sudden return to Earth. The control system was fairly simple, in theory at least. Throttle and sideways movement were controlled by rotating grips, like the controls of a motorcycle. When the pilot wanted to move forward or back, he simply had to lean to control the direction of the thrust nozzles. In this version, there was also a firing mechanism for 2 rockets, part of the campaign to convince the Army of the worth of the project as a potential offensive weapon. But there was still the problem of the 21-second fuel burn. An empty fuel tank 50 feet above the ground would also mean a sudden and disastrous descent. Something for the in-flight camera to record, certainly, but not desirable for the health of either pilot or machine. The answer to the problem of short fuel burn was to install a vibrating device in the back of the pilot's helmet to warn him when it was time to descend. This Bell Company film is presented as though the problem of short fuel burn time has been solved. It shows a number of potential practical applications, like cable laying in difficult terrain. As the camera mounted behind the pilot shows, the degree of control is considerable. The rocket belt is able to maneuver around difficult or dangerous obstacles with a high degree of precision. Although the Army was not excited by the rocket belt's potential, it was a natural for the movie industry. It was barnstormed around the world for money and had a career in everything from James Bond movies to sneaker commercials. The curiosity of the producers was no doubt aroused by the way the rocket belt was portrayed in this film, with its ability to be used in a wide variety of offensive situations, with its armament of bombs and rockets. Even apart from the short fuel burn time, there were still bugs. The accuracy of the rockets was quite unimpressive. A detour over water must have taken a lot of courage and a good sense of timing. The rocket belt was not the only rocket-powered personal transportation device the Bell Company experimented with. This is the Pogo, in which the pilot stands on a rocket-powered platform. It was tested at NASA's 1/6 gravity simulator at Langley for its ability to undertake transport and scientific missions on the moon. Another version of the system was this two-person platform designed for use on the moon or on Earth. In the 1960s, the problem of mobility on the moon was the subject of much experimentation, and the rocket belt was one of the vehicles considered. Tests were carried out at the United States Geological Test Site at Flagstaff, Arizona. Their purpose was to help NASA determine how a person flying a rocket belt could perform useful geological exploration on the moon and other non-terrestrial surfaces.
The Discovery Channel will return with Strange Planes.